Hello everyone, welcome back to the channel. And today we are doing the fifth part of the unit in geometry, which is circle. In our previous part we have seen how the angles are formed and they are related inside a circle. Those angles were formed by the segments or tangents or chords. Now we are going to know the length of the segments in a circle. So suppose two chords are intersecting inside a circle. This is one chord, this is one chord. Suppose this portion is D, this portion is A. I marked it so that it can be separated from each other. This portion is C, this portion is B. Then the relation between these variables are A times B is equal to C times D. A times B is equal to C times B. Let me take an example on this. So if I have a circle with two chords, if this is 3, this is 4, this is 6, and this is x, then how they are related with each other? 3 times 4 is equal to 6 times x. 3 times 4 is 12, 6x, so x is equal to 2. Easy? Okay, the second one. If two seconds are intersecting each other outside the circle, this is 1 second, this is 1 second, they are intersecting at this point. Suppose this portion is A, this portion is B, this portion is D, and this portion is C. How do we remember this, the formula that we are going to do for this? It is like outside times the whole, again outside times the whole. Outside is A times the whole means A plus B, outside times whole is equal to, again outside C times whole means C plus D. See, outside whole. So let me do an example on that. If I have 2 seconds intersecting outside, suppose this measure is 4, this outside measure is 4, this outside measure is 7, inside measure is x, and this inside measure is 10. Then what is our formula? Outside, which is 4, times whole means 4 plus 10, is equal to outside, which is 7, times outside plus whole, which is 7 plus x. So 4 times 14 is equal to, you can divide by 7 first, but that's okay, 49 plus 7x. So 56 is equal to 49 plus 7x, and 56 minus 49 is 7 is equal to 7x, x is equal to 1. Easy? Okay, now the next one. If there is a secant and a tangent, means this is a secant and there is a tangent. Suppose this is A, this outside is B, inside is C. Then the formula is outside this one, this square, A square equal to, again the same thing, outside times whole, outside times whole. That means A square is equal to, what is outside? B times B plus C. Are we getting it? Let us do some example on that also. Okay, if I have this, and this. Suppose this is 4 and this, oh, I did tangent, sorry. Let me draw another one. This and this. So suppose this is x and this is 4 and this is 5. So what is this? Outside square, this square, tangent square, when there is a tangent and secant. So x square is equal to outside, which is 4, and whole. What is whole? 4 plus 5, which is 4 times 9, which is 36. X square is equal to 36, so x is equal to plus minus 6. Length of an segment can never be negative, so we are going to disregard that negative sign. So we'll say the value of x will be just 6. Okay, these are the three main length of segments in a circle. This one, a times b is equal to c times d. This one, outside times whole, a plus b, c times c plus d. This one, which is tangent, and the second, a square is equal to b times b plus c. Now we will see some more special conditions, like if there are two tangents outside a circle. So I have already drawn the circles just not to waste my time. See, if you observe, these are two tangents to the same circle. The length of the tangents are always same. If this is A, if this is B, A is always equal to B. Length of tangents drawn from outside a circle from a single point are always same. You cannot draw more than two tangents from a point outside a circle. And the length of both the tangents to the same circle I'm talking about. And the length of both the tangents are always same. So example, if I have a circle with, actually I have a worksheet on that, rather I would do a worksheet on that. So like this question, I think it is visible. So one of the tangent is 22x minus 2, the other tangent is 20x plus 2. Since they are the tangent to the same circle from a exterior point, so the length of these two should be same. So 22x minus 2 should be equal to 20x plus 2. Subtract 20x, and this will be, take 2 there, so x is equal to 2. You got it? So these two are same, so I equated them. These two lengths are same, so they are equal. You will get the value of x. Okay, next property is tangent, not tangent, sorry, the chord and the radius. Like, I hope it is visible. Okay, if I have a chord and if I draw a perpendicular from the center to a chord, it always bisects the chord. It is always bisecting the chord. What does that mean? That means if I have a chord of length 12 inches, this chord is 12 inches. And if I say I have drawn a perpendicular on this chord with point P, what will be the length AP? AP will be 6 inch, PB will be 6 inch. I hope it is visible. Okay, here if it was not visible. So if I draw a perpendicular and this whole length is 12 inch, each part will be 6 inch. Each part will be 6 inch. That is another property of a chord. Another property is if I draw two chords which are of same length in the same circle, then the distance from the center to that chord is also same. That means if both the chords are 12 inches and one of them is 4 inches from the center, the other chord will also be 4 inches from the center. Another property I didn't mention in your previous in my previous video is if two chords are congruent, the arc related to those chords. This is the arc related to this chord related to this chord. So if both the chords are congruent, the arc associated with both the chords are also congruent. Means if this is 30 degree, this measure of this arc is 30 degree, the measure of this arc will be 30 degree. So these are the few extra properties that I have not gone over, which I am going over now. Now I'm going to do some questions based on the concept that we did just now. So let me see. Okay, here. This is the concept we did on the first one, like this. AB is equal to CD. So if this is 3 and 8, 2 and 3x, you can find the value of x. Pause the video for some time, find your answer, and then check. There are few questions, this, and this. You can pause the video, do it by yourself, and I'm solving, and then you can check your answer with me. So this is 3 times 8, which will be 24, and 2 times 3, x. 24 is equal to 6x, so x is equal to 4. In this case, it is x square is equal to 9 times 4. So x square is equal to 36. X is equal to 6. We are not going to take the negative value. So I have not taken the negative value. Just the positive, because negative length can now never be negative. This question, it is outside times whole. So 4 times what will be whole? 4 plus 6, which will be 10. Outside 5, and what is whole? 5 plus x. So 40 is equal to 25 plus 5x, or you can divide by 5 also. So it will be 15 is equal to 5x. So x will be equal to 3. Same thing goes here. So it is 4 times x, 4 times 4 plus x outside times whole equal to, again, outside times whole. Whole is 5 plus 4, which is 9. Okay, so 4 16 plus 4x is equal to 9 times 45, 29. 4x is equal to 29. X is equal to 29 over 4. You can put the answer in the decimal. You can use a calculator on this. There are a few more questions on this page. I can show. If you want to do the extra practice, you can go ahead and do it. And if you have any question on this, you can text me, or you can put it on the comment. If you're my existing student, you can reach me out. Okay, I can have few more questions if my video is not done. Yeah, I can go few more questions. I want to go over this one. If you remember, in my previous video I said a radius and a tangent are always 90 degree, right? Here the question is, determine whether this segment AB is a tangent to the circle or not. It will be a tangent to the circle if this angle is 90 degree. So that means we are going to do converse of Pythagorean theorem. So if in this triangle, if I can show 7 square plus 12 square is equal to 15 square, then this angle will be 90 degree, and then this segment will be the tangent to the circle. So let's see, 7 square plus 12 square, which is 49 plus 144, which is 169. No. 193, my bad. And 193, 49 plus 144 is 193, and 15 square is 225. So they are not equal. That means 7 square plus 12 square is not equal to 15 square. So this AB is not a tangent to this circle. Let me see some other question. Let's see this question. So is this segment AB is tangent to the circle? And I can say it's a Pythagorean triplet. 8 square plus 6 square. 8 square is 64 plus 36, which is 100. And we know 10 square is 100. So yes, 8 square plus 6 square is equal to 10 square. So that means by a converse of Pythagorean theorem, this is 90 degree. And this is the property of tangent, that a tangent and the radius should be perpendicular to each other, and it is so here. That means AB is the tangent to the circle. Okay, we just did in the same video where I showed you, if there are two tangents to the same circle from an exterior point, their lengths are same. There are a few more questions. If you want, you can go ahead and do work on them, and you can text the answer in the comment box. Okay, and I think I have covered almost everything. Let me quickly check if you guys need anything else on this packet. Yes, I think I'm done, pretty much done on this. I will continue on more questions in the second part. So yes, if you like it, if you like my video, you can like and subscribe, share with your friends, and thank you guys.